Good to start? Cool, okay. Well, I have a lot to get through, so let's get going. So I'm David Laskey, hopefully you're in the right place. This is Anticipating New Platforms, porting TumbleSeed and Nintendo Switch. We launched our game earlier this year on Switch, not long after its release, and I just want to talk about some of the things that we did in order to, I guess, already be ready to move to a platform like the Switch, even with it being entirely new. And yeah, just give you guys some tips to be able to do that more smoothly. So hello, I'm David Laskey. I'm from Chicago, and I mostly do freelance programming and lately porting. I've helped a bunch of other Chicago and Midwest indies do ports of their games. These are the ones that have launched at least. There's Race the Sun, which is by some guys in the Midwest. I helped with the Vita and Steam and PS4 versions. Oregon Trail Complete Edition, that was a mobile game and eventually got to Steam, but I helped with the PlayStation versions as well. TumbleSeed on Switch, PS4, and Steam. That's why I am here today. And Battle Chef Brigade is coming out on Switch and Steam soon. I don't know if they announced a date, so I'm not going to say anything. It should be soon, but look forward to that, and that's going to be on Switch. And I used basically a lot of the same code and techniques that I did on this project for Battle Chef. So again, it's really helped me with this process throughout the last 2 years of porting stuff. Also, I'm going to have a bit more to talk about than I have time for, so if you go to this link sometime after the talk, I'll have some follow-up notes about things that I didn't get to and some more in-depth information on stuff that's a bit too heady for, I think, a talk like this. So, and feel free to tweet at me any questions or just say hello. Anyway, so what is TumbleSeed? For those of you who don't know, let's see. Is it going to give me internet? Did my internet die already? It did. Well, I do not have a ton of time. I will show you in a moment. So let's just get to this then. So Team TumbleSeed, it was originally these four folks. You got Benedict Fritz on the left, Greg Woolen in the center, original programmer, lead programmer, and then the artist is Greg. Jenna did our logo and some marketing, and Joel Korlitz did all of our audio and sound effects and music. I'm not in that picture, but I'm still here, and I worked on the game. And our friend Bryce did QA towards the end. They were pretty invaluable. Get a QA person. I'm going to hammer that later, but get a QA person. So our original timeline, Benedict had a prototype in the fall of 2014 that was, for those who don't know, TumbleSeed is about a ball rolling on a bar up a mountain. So there's a vine, there's a seed on it, you roll back and forth. It's a roguelike, so this mountain is randomly generated every time, and you have to scale the entire mountain. And it's a roguelike, so you basically are starting over from the bottom every time. And so Benedict prototyped just a physics toy of a ball rolling on a bar back in 2014. Again, I linked to a different talk of Benedict and Greg's from Fantastic Arcade last year where they talk about designing that game, but it took them about 1.5 years to come to what TumbleSeed ended up being as a system and implementation of that toy. So I joined in May 2016 to start the porting process, and originally we were only going to be porting to Steam and PS4, and I'd done both of those a few times, so I was very comfortable. The only thing that we were doing with TumbleSeed is leaderboards, which Oregon Trail had cloud saves, and Race the Sun was doing 3 platforms. It was PS3, Vita, and PS4, and this was just PS4, so I didn't have to talk to anything else. It seemed totally doable. The thing is, the game itself took longer to finish than the porting work, and so originally we were like, okay, maybe we'll release in January because, winter time is more the AAA release window, not as much a good time for indies to be releasing. So what actually happened, that was our original plan, and even January was the original plan at one point. But what actually happened is we cold emailed Nintendo around July being like, hey, Wii U, 3DS, does this seem like a fit for TumbleSeed? And this was when it was still the NX to the general public, and Kurt got back to us and was like, hey, you should check out the NX. We should keep in touch. And so we followed up on that, and eventually we had TS running on the Switch, TS being TumbleSeed, running on the Switch. At the beginning of December. I searched my email for dates to fact check myself, and I think it was December 2nd or 3rd, I emailed Kirk a video of me playing TumbleSeed in a poorly lit room in the winter in Chicago. So it was running, and I say running because the frame rate was pretty bad, load times were atrocious, but it was running. And so Unity already had us basically within a week or so of getting kits and everything. We had TS running, and that was really cool to see. And then we released on May 2nd this year. And so to zoom in on the timeline a bit for porting, again, we had the game running in very beginning of December. There was 2 weeks in December where myself and our artist were out of the country, so we weren't even working on the game. So about 2.5 months, we entered our first pre-lot check submission. For those who don't know, lot check is Nintendo's certification pipeline of sorts. And so we did a pre-lot check submission, which means the game isn't done, but we want to test leaderboards and all of the things that the different consoles and publishers usually have you kind of quality assurance test to make sure their platform has a consistent user experience, right? So displaying certain error messages, making sure controllers work the right way, all the features that are specific to their platform. And every platform will have you do this. And so you can do a pre-check with them, which is a way to not screw yourself over later when you blindly submit one check and hope that it passes. Because if you don't pass, you don't release. That's a hard stop. So we did, I think, 2 pre-checks, and that was very useful. Highly recommend doing that. And we did our final lot check submission in April, and we ended up having a day 1 patch on Switch, and I think that went through on May 1st at 8 p.m. So May 2nd is when we released. So just to talk about how tight that window was, even having ported a bunch of stuff before, this still happens. So basically, I want to look at some optimizations that we went through to get the game ready. We're a 2D game. TumbleSeed's it's a sprite-based 2D game, so it didn't take a ton of work on that side. But there was still some issues, and then sharing some surprises and useful tips when it comes to porting and setting up your code architecture, and hopefully having you feel more confident than when you first walked in, as far as the porting goes, and just, I guess, approaching game development with a multi-platform simultaneous release in mind. So let's start on optimizations. So when I first sent Kirk a build of TumbleSeed on Switch, we had very long load times. I think it took like 40 seconds to a minute to even get into the game. And an inconsistent frame rate. Now, most of the time, the frame rate was somewhere between 30 and 60, but it was more about frame spikes that we had issues. And that was mostly garbage collection for anyone aware of, again, any programmers out there. So I'll talk about how we reduce some load times and fix the frame rate. So when you start the game, and again, sorry I wasn't able to play the trailer earlier, but basically, on the far right is the entire, I guess, play session of TumbleSeed. You start at the bottom of a mountain and you scale the entire mountain. And so what you see on the screen at a given time is on the far left, and probably even a little less than that. If you can make out some of the white outlines on the screen, that's about what the camera size is. So it's about 1/5 or 1/6 of the entire biome, what we refer to as a biome. And the first biome on the mountain is the forest. And if you zoom down even further, there's the forest, then there's a jungle section, a desert section, a snow peak, and then there's a boss. So it's like 4.5 of these biomes. And so originally when we had the game, it was just going to be, again, PS4 and Steam, it would spawn this entire mountain procedurally every time we'd go to play. And on those platforms, it wasn't an issue for us in the past. Desktop, it was hardly an issue. But when we started moving over to the Switch, we had to make a few optimizations to make sure that Switch players weren't waiting 20 seconds to restart anytime they went to play. Because in TumbleSeed, you die a lot, you restart. It's a roguelike, so you're always starting at the bottom. And so if you die and you have to wait 20 seconds every time you want to play, especially with like a pick up and play experience like with the Switch on any game, that was pretty unacceptable. So what we ended up doing was breaking up the spawning into one biome at a time, which may seem like an obvious thing to do, but we were pretty married to this one, there was never another load time after that. It was always this contiguous, you're always just going up the mountain, which was really cool. But what we ended up doing was, if you see on the left here, at the very end of a biome, again, TumbleSeed hits a springs out of frame, the screen fades out, we actually spawn the next biome, and you come to land in like this little camp area before the next section, and this is like a safe zone where there's no enemies or harm. And this ended up playing nice as a pacing moment too, because as peaceful and chill as people say the game is, it is kind of stressful too, it's difficult. And so this was actually a nice moment for players to take a break. You know, you mentally are like, okay, this is kind of a checkpoint in the game. And so it worked pretty naturally, and it only takes about 2 seconds to spawn one of these biomes. So it really didn't feel like a loading issue at all at that point. We didn't have object pooling, and for any programmers in the room, you're probably saying that's like the first thing you do for optimization is make sure you're not calling instantiate during the game. This did help. We started tinkering with it a bit. It helped for the mid-game load times, but the front end, it made our booting up the game load times even longer. Even today, it takes about 15 seconds to load the game up front because we load everything in the very beginning and then don't really have any assets to load after that. So when you're playing and restarting, that's quick and smooth. We also had kind of like a spaghetti code set up, and we're trying to pivot to making everything run. And when we weighed the amount of bugs that it was going to potentially cause with the performance gains from mid-game, we already had enough gains from the switching over to that world breakup optimization, so we decided not to do it. So I'm not saying don't do object pooling. I'm saying this is the choice we had to make, and as someone who does porting, it felt wrong at first, but it actually was the right choice for us because we were able to ship, and the game runs fine. So that's just something to keep in mind, is make the choices that are right for your game, despite someone waving best practices in your face. So inconsistent frame rate fixes. So on the right, you can see what the player would see in a typical session of TumbleSeed. And on the left, we ended up doing what we called world calling, which we just have a lot of physics objects in the game. There's triggers everywhere for falling. All those black circles, if it's hard to tell from the screen, those are holes you can fall into. And so basically, you're rolling around avoiding enemies and holes and using different power-ups as the player. And so again, there's that white rectangle on the left. As you see it move up, that's actually the camera that you're seeing on the right. And so what we do is we disable chunks of the world and different enemies if you're a certain Y distance from the camera. And this just allowed us to get our frame rate pretty consistently at 60 instead of bouncing from that 30 to 60 based on how many enemies or the complexity of the biome. This kept it pretty consistent. And then the only thing we had to worry other than that was for those frame spikes, which I'll get to in a moment. So yeah, this was what was active before we implemented frame calling or world calling, and then on the right you can see basically it's just a very trimmed down version of things being active. And so if an enemy goes off screen a certain amount, it will stop chasing you because it is inactive, and players pick up on that. And that's fine, it's a valid strategy. That's actually a good way to play. So the other thing we did was dancing with the garbage collector, as we all do. Having no object pooling did have us have to do more with this than we would have liked to, because you are creating garbage if you're doing all this instantiation during the game. Obviously, avoid instantiate calls if you can, using the non-alloc variants of physics functions. So we switched all of our ray casts and capsule casts and things like that over to the non-alloc versions, pre-allocate arrays of colliders and use those. You also take steps to reduce the automatic GC collects. Those were the biggest culprit of our spikes, right? If you're generating garbage over time, the garbage collector is going to sometimes decide, I'm done, and it's just going to decide to wipe on its own, and that's where we'd get our performance issues. And TumbleSeed's about smoothly rolling on a plane, so that wasn't going to fly. So basically, we had to try and take control as much as we can of that, along with finding clever times to hide our own calls of GC collect. And so this is actually a trick. I linked to this is from straight from Unity documentation. I linked to this on that bit.ly link from before. But basically, this lets the garbage collector apparently kind of expands this diaphragm that the garbage collector has for when it decides to collect. You allocate a block of a large block, and as you see, it iterates through of then tiny blocks, and this apparently makes the garbage collector not it tricks it into being more lenient and waiting longer to collect, and so it would not trigger as frequently for us. They explain it more into, I'm not going to pretend I'm a garbage collector expert. They explain it a little more in the documentation. You can read on your own. But instead of just doing this, we did 200 megabytes worth. So literally on Switch, the first thing we do, there's a script that only runs on Switch that just says, allocate 200 megabytes of garbage and then release it immediately. And then that just made the garbage collector fire off by itself less. Profile this first. Don't just throw this into your game and say my game's fixed. Programming's cool, huh? Why does anyone have to do this? It's goofy. But this is something that worked for us. So profile it, look into it, don't swear by it. The other thing we did was just anytime the game pauses or it was convenient, in TumbleSeed you hit the action button and then you're able to switch seed abilities, and so anytime we did this, the game literally pauses and the game world freezes, and then this menu you scroll through. Basically, this was a perfect time for us to call GC collect because it's a point in the game where you inherently have to pause So we do this. This is basically the main mechanic of the game other than rolling. So it worked to our advantage, and we just call garbage collect in case it needs to then, and so it kind of keeps resetting its quota. Obviously, when the game normally pauses, and other scene transitions. So when you go inside the mountain and it does the fades, or as I showed earlier, when you transition to the next section of the mountain. So that was most of the optimizations. Other things like don't use on-trigger stay, I don't think I really need to go into detail about. You can, if you want to use on-trigger stay, you can wrestle with that later as I did and then have to dig it out of your game, so just don't do that. But yeah, so I'm going to get into the more platform integration stuff now, and I'm going to try and go fast because there's a lot, but I also want to make sure I'm clear, so hopefully I don't go too fast. But normally, when porting, Unity has all these preprocessor defines that you say, oh, okay, I'm running on desktop, I'm running on PS4, I'm running on Switch, and so you have like branching functionality that maybe use LOD versions of like, oh, we're running on Switch, so maybe our particle effect might not be as high fidelity as if it was with like my super high graphics card computer. This kind of gets messy to read, especially if these if-def everythings are all over your game code, and it's kind of a nightmare. And also makes debugging kind of difficult because you can't follow a single path of game execution as you're just working on your game. And so this becomes a mess. And so trying to avoid this, we switched over to decoupling our code from the game code from the platform code. So abstraction is your friend here. Again, this is, for programmers, this is just like simple abstract classes. We have a base platform class that has all of the function signatures of things we need to do. So rather than say like, hey, initialize the game, and then having those if-defs in our initialize function, we just call one function that says platform.initialize, and this abstracted interface deals with what that means. So Benedict was working more on the game stuff. I was working more on the platform stuff. And so he didn't have to care about what the platform was doing. He just knew what it was supposed to be doing. And if it wasn't doing that, then you knew the bug was somewhere in the platform interface, not in the game code. Again, this helps isolate those like preprocessor directives and as well as helps debugging. So here's I haven't done UML since college, so this was a nice little refresher. I think this is right. Just to note, base platform is a mono behavior. So here's a very trimmed down version of our like platform interface. Basically, let's just say there's an init and a shutdown function, and we have a static wrapper that on start creates an instance based on what platform you're on, and then you just reference that static wrapper the rest of your time playing the game. And so here's like an example, excuse me. So we have a single point of entry when you start the game, which I also recommend for anyone doing porting. Make sure you can focus it like exactly where your game starts. This helps for either DRM or initializing platform services. And so you can see here, this is like literally, without all the extra TumbleSeed specific stuff, this is basically how our game starts. We call platform set platform, it knows what platform it's on. And then we spin off a coroutine for if the platform has stuff to initialize, do it. And then, hey, check for a save file. And if you're successful in loading that save file, call the onload success callback, otherwise call onload failure. And those are coroutines because loading is not always a synchronous function. And even if your platform, it is a synchronous function, then that's fine. This basically allows for platforms that don't have synchronous loading to do so. And also just to show you where our if-defs happen, inside of this set platform code is basically the only place we have these preprocessor directives, where we just create a blank game object, throw on the right component depending on what platform you're on, and then just flag it to not be destroyed for the duration of the game. So assume most things are asynchronous when you're doing platform implementation. Again, I'm going to not break any NDAs, but basically different platforms handle things in different ways, and where you could just use what system file write on desktop, other platforms and consoles don't necessarily have those functions available. So you want to basically adhere your platform interface to the most complex needs. So if one platform, for example, only works with save files as bytes, whereas on desktop you can say, oh, I'm just going to write a string to a text file. Basically on the game side, make sure all of your save data ends up as bytes, and then have your platform interface deal with bytes, and then all of your code is like the same for every platform, and then the platform knows how to deal with bytes, if that makes sense. System actions, if you're unaware, these are basically just almost like delegates. You can, as you saw with the onload success, onload failures, those platform callbacks, an action is just like a blank void function And this lets you keep your game code in the game side and not getting mixed into your platform code. So as far as the platform is concerned, there's 2 callbacks in that function. There's a success and a failure. And it doesn't know what they do, but it knows based on its own operations, oh, I failed to load this save file, so I'm going to call the failure. And also create enums for platform-related errors. So on that onload failure callback in that platform load function I showed, we pass back why it failed. Was the save corrupted? Was there no save file found? This is important when you're going to do different platforms certification. Sometimes you need to show the user why something happened. So if it didn't operate as expected or something went wrong, you need to be showing the user those errors. So have your platform tell the game why the errors happened, and then just have your game deal with all the errors the same. And that makes, again, the porting process so much simpler rather than having to re-implement the error catching every single time. And you have this branching code of where do my pop-ups show up and everything. OK, so I'm going to get now into just a brief mention of custom native plugins. So this is a bit heady for this talk, and this is where I put most of the blog post I linked to in the beginning is about this. I didn't want to have everyone staring at a wall of code at 9 in the morning, and I hope that this is still not too much. But I don't hear anyone talk about this ever. Everyone just kind of assumes that Unity provides these for you and that it's all fine. And they provided most of it for us, and it was really great, and they were extremely helpful. I don't want to dog them at all for it. But sometimes it's just like we were one of the first games that came out on Switch using Unity. And so some stuff wasn't necessarily ready that we specifically needed for our game. And so we had to go in and make some of our own implementations of native functions. Also, there's been times in the past where maybe a Unity wrapper has bugs in it or might not be up to date with the latest certification guidelines. So if guidelines get updated and Unity hasn't updated their plugin and you need to release, what do? You either shrug and say, I'll wait for Unity, or you can dive in and do it yourself. Native plugins are also super helpful for even desktop platforms and like iOS. This function, like the setup that I'm showing you, kind of works for everything, and it's basically what I've come to use as like the easiest way to do it. Again, I'm not garbage collector expert. I'm not some C++ guru. I'm just some guy who tinkered and figured it out, and so hopefully it encourages you to do the same, because it's not as scary as it seems. So here's a simple example. If you have to do native plugin stuff, this is on the C++ side. You just have some global function. This is just it could be doing whatever. You could be calling like like a network update to make your callback start firing off in case your network needs to propagate, or just some other simple platform function. And just wrap the global function inside of extern C with brackets that apparently deals with some name mangling, I think it's called. That C++, when it goes to do some linker stuff, this basically makes it happy. I can't tell you the inner workings of C++, but this makes it happy, and I've never had a problem with it. And so then on the C# side, there's this namespace system runtime interop services and a DLL import attribute that for static libraries and most non-desktop platforms, you just flag with internal. And this otherwise, it's normally the name of the plugin that you have. The entry point is just the name of the function. So my CPP function was the same name as the function that I showed you in the other screen. And it doesn't matter what your parameters are, your return type. It's always just going to be the function name. And then the calling convention is just C declared. There's some variants of that, but again, this is the easiest, most simple one that I've dealt with. So yeah, that's it. So if you want to call that native function, all the platforms have basically a templated, simple, empty plugin that you can use. And I think even Unity provided an example for creating one. And so this is kind of the bread and butter. You have this static extern call to a library, and then as long as the function names match up, you can call them. Things I don't get into are, at least in these slides that I do in the blog post, are passing data between C++ and C#. So sometimes you're like, I just want to call this native function. It does its own thing. Our problems were we needed to get data back from C++ and send it to C++. And so doing things like sending ints, floats, and bools, even return types, that's all the same. It's very simple. But doing things like strings for usernames and file names, data blobs, and save files with byte arrays, that stuff gets a little more complicated, and that's what I put in the blog post and didn't want to drown you all in this morning. So yeah, there's the link again if you need it. But that stuff is super important, and we would not have been able to ship without doing that ourselves. And I think Unity now has taken care of most of the functionality that we didn't have at the time. But again, you might still run into an issue for something that you need. So I encourage you to take charge of diving into this stuff and not be too afraid of it. Okay, so some logistical insights. Get familiar with the certification and the platform backend that you're on. The moment you get access, dive into their cert documents, go dig around the website, get familiar with the stuff you need, and even be in touch with your release manager about the steps it takes to release. Because if you're not familiar with the certification guidelines, as I mentioned, like, oh, my save file was corrupted, what pop-up do I show, what do I show them? If you didn't plan your UI around this, and so let's say you have a game that's already released and now you need to port it to something, and oh crap, my UI doesn't really anticipate these type of user pop-ups and user notifications that I need to let people know about. It's really painful to change that stuff. You need to redesign entire interfaces. So we had a very simple one that at the time was cert compliant. I'm not going to say, again, I don't want to go into details about what it needs to do, but I very much worked with Greg to be like, hey, before we design any UI, let's make sure that they take these things into account. And so read the guidelines for the platforms that you're going to be on. Make sure that all the errors you need to show and all of the, I guess, guidelines that you need to follow are taken into account when designing your UI. UI especially. Your game can usually kind of bend as needed, but UI particularly. Do pre-cert checks if you can. We did too, and we had a lot of bugs and things that came up in both of them that we would have definitely failed on and missed our release date if we hadn't. So again, work with your release manager, contact the cert teams if you can, and yeah, Nintendo's was amazing to work with. They definitely did a lot of work for us to make sure our game got through, and we really appreciate everything they did for us. And also make sure to fill out any forms and set up oh, well, our game's not coming out for 6 months, and we don't need leaderboards yet, so I'm not going to worry about telling them that they need to have their servers ready for our leaderboards. Do that ASAP, because that is not a thing that they just turn on. That stuff, you have to submit for it, and there's a back and forth process. So basically, as soon as you can do anything, do everything. Is kind of my general headspace. The moment I jump on a project, I'm like, what services we're using, save files, leaderboards, what do we got? Get all of that in the pipe so you don't get stuck later. Also, make sure you look into the needs for store assets and releasing. We actually released on PS4 in Europe on May 3rd because we submitted our store assets too late. And that stuff has some hard amount of time that it takes. So oh, hey, we submitted this too late. Can you just do it? No, they don't need to bend to you, and sometimes they literally can't. They have how many people are in this room? Imagine how many people around the world are submitting games to all these platforms. So they don't always have time to bend to your last minute, push things through the pipe. So yeah, we missed our deadline by 1 day, and so it came out on May 3rd. But that's something to be aware of, and something that we could have been a little more on top of. So be looking into literally everything about your release as soon as you can. Be willing to pivot sometimes, because sometimes Unity has bugs, which we love you, Unity, but yeah, sometimes you can't wait for those bugs. So this is even separate from the native plugin thing. Sometimes there's engine-side bugs that you can't fix. Maybe physics broke someplace. Maybe fonts just broke at some point. Work around the problem rather than fighting it. So for us, we had a point in our game where anytime you pull up that seed menu for all the different abilities, it would show videos, and these are static images, but we had videos playing, and there was this Unity side bug where the video thread would get stuck, the whole main thread would get stuck in the video process thread, and the whole game would hard lock. And I spent a month or so trying to work around it, and we had to shift through 30 videos at moment to moment, at any given point, and that was all nightmare. We switched to static images that were more helpful and clear than the videos were, because the videos were kind of low quality and skippy to make the file size low. This was a much more elegant solution, and we worked around the problem rather than just hitting our heads on it anymore. So I wish I could have that month of my life back, but that's not how games work. So, and have the dedicated QA person. Again, we hired Bryce, and they basically destroyed our game for a month straight and then made it so that it was playable for everyone. I can't even, the amount of bugs that they were able to find still blows my mind. Have someone who knows how to break a game, hasn't been playing your game for 2 years every day for 8 hours, and has a skill and an insight to these certification hiccups, because then they can kind of anticipate how your game will break. Okay, so I think I'm basically out of time, but some quick takeaways. Be ready and willing to learn and on the fly and adapt, because a new platform, especially one where games haven't been released yet, you're going to be out there on your own swimming in the deep end, and you just got to be willing to take whatever comes at you. Get familiar with each platform's cert guidelines and backend. So get yourself familiar the moment you can. Again, as soon as you can do anything, do everything. Just dive deep in there. And some decisions will feel hard or wrong in the moment, but are likely necessary for your specific game. So we have no object pooling. We have a very simple yet ineffective way of loading prefabs and assets and stuff. But that was our game, and we did what we needed to ship. And I would not recommend doing either of those things for anyone's game, but it was in our game, and we had to work with it, right? And that's it. So I don't know if there's time for questions, but if anyone has any, that's all. Thanks. 5 minutes? Sure, yeah. So if anyone has questions, or feel free to step up to a microphone. That was all a blur. I just kind of rambled for half an hour straight.
That was great. Thank you.
Thank you. Appreciate it.
Were you processor bound or graphics bound on the Switch?
Absolutely processor bound. Yeah, it was we had, so 2D game, especially graphics wise, we were fine. We never had a problem with graphics. It was mostly, we had a lot of physics, and our physics update was it was faster than 60 frames too, because we ended up wanting it to be like even a smoother roll on the bar. And so we were definitely physics bound. So it was mostly just finding out how to minimize, like optimizing our collision matrix and disabling as many physics objects as we can. So, yeah.
What were your frame rates like, or what were your load times like on Steam or PS4 comparatively?
PS4 and Switch were fairly similar at first for load times. Right. I think Switch was a little bit slower, but ultimately it was more about the runtime physics stuff than the load times. Because load times, honestly, any console is going to be worse than desktop. But yeah, that was what we found.
What were they like on desktop, I guess, is what I'm wondering.
Load times, it was usually like 5 times faster. Like the game would boot up like almost right away, and then any console, even PS4, it like took longer. And so it's just how do you try and unify that experience for the user.
Great, thank you.
Yeah.
Hey, do you have any tips on debugging when you're using C++ native plugins? Because I've had to deal with that before, and it can get kind of messy where you're just crashing and not knowing what happened.
Yeah, and well, one thing I would say is try and have fun also debugging IL to CPP sometimes. Like read their blog post on getting in there. Yeah. What I do is I usually make like a small just like main function on the native side. So like I made like a native Switch app that was just a main function, and I just like took one of their example projects and reworked it and tested all my plugin functionality in that, because rather than having to rebuild 20 minutes every time using Unity, I was able to quickly iterate in the separate project that was dedicated for testing like the plugin functionality specifically. So try and basically get Unity out of the picture when you're testing those plugins, so you don't have to keep rebuilding every time.
Cool. All right, thank you.
Yeah. You in the back first, actually.
Okay. So you mentioned that you guys emailed Nintendo to get the dev kits.
Yeah.
Can you share any advice on the best way to go about that so that you can get a good response back?
I would say go talk to Kirk and Sarah in the back row from Nintendo. They're here joining us this weekend. Kirk and Sarah both were part of the process of us releasing TumbleSeed, so they were our go-to, as well as Justin here in the front. So yeah, I'd say talk with them and just show them your game. Have something that you can be excited about and that they could be excited about, and why your game is so at home on Switch, right? Like we didn't design TumbleSeed knowing about HD Rumble, but like once we found out about HD Rumble, it was such a perfect fit for our game, and like taking advantage of that as developers and like realizing that you can tap into something that's platform specific, which players always love, and also gave us a sixth sense in our game, was like, that was a perfect fit, right? So find out reasons why your game or project also has a home on Switch, and yeah, go talk to them.
Cool, thank you for sharing your knowledge.
Yeah.
Going back to the native DLLs real quick.
The what, I'm sorry?
The native DLLs?
Sure, yeah.
When you're dealing with that, in the Unity editor especially,
Yeah.
The second you load a DLL in there, then you press play in the editor, trying to then override that DLL can turn into a bit of a nightmare where you have to restart the entire editor.
Oh, yeah.
Did you have any solution for
So
that?
what I do is actually, so the DLL, I didn't write a variant that ran on desktop, and so I actually, so you know how we had the switch plugin interface, and there was the, let me see if I can just jump to it, because this will be faster to reference the UML doc. UML that I know so much about. So we had switch platform and DRM platform, right? And so the set platform function I showed you was a little bit simplified. I actually broke this down even further. If you're on a console and you're an editor, I would just load DRM free platform.
Okay.
Does that make sense? So anytime you're on desktop, it would just use that. Or I would use Steam, because Steam runs on desktop, to simulate the game side. And then, for doing it on consoles, it's just once it builds out, then I would test it there. So it wasn't perfect. And there was some ways, I don't know if it's still possible with the way Unity, again, I don't want to break NDAs, but you could also just like replace your native plugin after building from Unity, and then you had your native plugin sitting, and then I could just stamp over the old one rather than having to rebuild the whole project. So that's how I would iterative test with Unity, I guess, once built out.
Yeah, thank you.
Yeah. I think that's it. I think we're good. Thanks so much, guys.